To build complex agentic systems, you need your agents to be able to make concrete decisions that affect the flow of your application. Not only is our insights team generating cool insights for us, they're generating it in JSON format. We have 2 innovation files because our round robin ran twice, all of our chat team logs we can dig into, and we also have the run SQL result. We now have the ability to make decisions based on our agent's output, and we can now have our agents generate specific structured output. It could be argued that the 2 agents we're going to build in this video are 2 of the most important agents. The first agent type gives your multi-agent systems the ability to drive autonomous decision making. Your agent is going to be able to answer a question and then consistently provide specific output responses that then drive action in your application. The second agent type enables you to generate structured responses for your LLMs. That means no more prompt engineering magic to get the output you're looking for. You'll be able to use your agents, ask specific questions, and get structured responses in any form you want. There's a sweet spot between the uncontrolled, non-deterministic, generative capabilities of LLMs and a program that runs top to bottom the same way every time. In this video, we're going to find that sweet spot and solidify repeatable engineering patterns we can use not only in our Postgres data analytics tool, but in every multi-agent system we build from now on. In order to integrate autonomous decision-making and structured responses into our Postgres data analytics tool, we're going to merge 2 great code bases from Microsoft. We're going to be using AutoGen, the multi-agent framework we've been building on throughout the series, with Guidance. Guidance is a tool that enables us to control our LLMs more effectively. It utilizes a handlebars-like templating syntax that allows us to make selections, build conditionals, and generate specific structured outputs. At the end of this video, we're going to talk about the code base we've been building up over these 6 videos. So stick around for that. That's going to be somewhere near the end of this video. Let's not waste any more time. Let's merge Guidance and AutoGen for agentic decision-making and structured responses. So first things first, as always, let's run a simple example to show off our application. Poetry run start, pass in our natural language query, which is going to be a prompt against our database. So we can type in natural language and get results out of our Postgres database. We're going to look at the product, and let's just say I want to get the most expensive product. From our products table, show the most expensive product, return the product name and ID. So our multi-agent application builds a prompt, generates the SQL statement, runs the statement, writes it to a file, and reports everything that's happened throughout. So we can see here it successfully ran, and thanks to our work in our previous video, we can see that we have a folder here called Agent Results. We can see we have a couple of runs here in our latest run, and we can see that it returned product 89, product ID also 89. And if we hop back to our result here, we can see that's exactly what we were expecting. So in natural language, we can query against our database. How do we accomplish this? It all starts out with the prompt. So we're using argparse to pull in our prompt. Once we have our prompt, we prefix it with fulfill this database query. We build a session ID that marks the run of this agent system. We then open up a new block of code with our Postgres agent instruments. We pass in the database URL and the session ID, and it gives us back agent instruments and a database structure. You can think of agent instruments as a store-like structure that our agents can use to call functions and reference specific state. If we open this up, you can see we're building out table definitions using some embeddings and some simple word matching. We're then adding those table definitions to our prompt, just like you can see here. We have a list of tables getting attached to our prompt. That's great. We're then using our orchestrator to build out our data engineering team. Our data engineering team is then using the sequential conversation, which runs top to bottom, and then we're using the new Python 3.10 match statement to analyze the conversation result. We're looking to match on result is true, and then we're looking at the cost, and then we're reporting our result there. We also have a full log of our agent conversations, so you can see that our admin talks to our engineer talks to our data analyst, and then our analyst calls the function to actually write the SQL and run that entire flow. So this is our Postgres AI analytics tool so far. Now that I've walked through the code several times and I'm talking about it out loud, it's pretty incredible what we've done so far. If you want more details, if you want to see how we got to this point, check out the previous 5 videos. I would definitely recommend you start from start to finish. It's going to make a lot more sense coming back to this point. I know it's getting kind of hard to follow, but we're stacking up everything we've done, and we're going to end with a really cool system here, especially after this video. Let's talk about flow control with agents. So in a production-like environment, our prompt could be passing in anything, right? We could get complete junk. We could fat finger some bad prompt. A user can just type in random text into this prompt coming from a front-end user interface. A lot of things can go wrong when figuring out what's getting passed into this prompt. This is the perfect use case to build out our brand new agent to help us drive decision making in our application. So what we're going to do is, based on our input prompt, if this is just complete junk and it doesn't make sense as an SQL natural language query, we're going to filter it out. We're going to log a response and say, hey, this is not something we can process. So we'll be able to just filter that out completely. On the other hand, though, if we get a valid query, something like all auth users, we want to allow this to run through our system. So what we're going to do right now is build out a new decision agent that allows us to control the flow of our application. Let's code that right now. Okay, we now have a brand new gate team. This gate team is powered by our Scrum Master. And if we just look at the high level here, we can see that our gate team with our Scrum Master agent is now filtering out if this prompt is not a valid natural language query prompt. Right, so we're getting the confidence here based on the response of our orchestrator. Our orchestrator contains our team and their result. And if we're digging into the last message string here, so the last thing that was said in the conversation, we're then casting that to an int and using a match statement to drive the flow of our application. So you can see here, if confidence is a 1 or a 2, the gate team is going to reject this prompt. Also, if for whatever reason our agent returns complete garbage, we just reject and move on. But when we do get a 3, 4, or 5 confidence level, we will continue running our application. So you can see here there's no return statement in our 3, 4, or 5 case, right? Then we just continue, we proceed with, building out the table definitions, right? Build tables. So this is really cool, right? We now have an agent that can help us control the flow of our application. So let's dig into this Scrum Master team and see exactly how we did this. So if the team name is Scrum Master, in our build team orchestrator function, we're now building this new team, build Scrum Master team, with 2 agents. Use as few agents as you need to get your job done. So you can see here we have a brand new agent type called Defensive Scrum Master Agent. And this is a reference to, there's some teams where you have concrete Scrum Masters. Usually these are just your product managers. A good Scrum Manager will filter in and out work for the engineers and for the team. They'll defend the time and the roadmap that's been set up for the team. So that's the idea for this agent, right? It's going to protect our application. It's going to protect our downstream agent teams from needing to run garbage tasks that don't make any sense for them to run right now. So let's dig into this prompt first. We'll dig into the prompt and then we'll look at our custom agent. Let's look at this prompt, right? This is a guidance prompt. So now we're digging into the magic of guidance. The kicker is all in this last line here. Select rank, and then it's saying choose 1 or 2 or 3 or 4 or 5. And it's wrapped in this handlebars like syntax. We have this, select statement here that's saying select one of these values based on the content from the rest of the prompt, right? And the rest of the prompt is saying this: is the following block of text a SQL natural language query, NLQ? And we're ranking that confidence from 1 to 5, where 1 is definitely not, 2 is likely not, and then 3, 4, 5 is on the positive side. And then as a templated variable, we're able to pass in potential natural language query. And if we hop down to the agent here, this is our defensive Scrum Master agent. This is the agent that's actually getting built here. Instead of the usual AutoGen proxy or AutoGen conversible agent, we're building our own defensive Scrum Master agent. And this is really cool. So let me show you how you can build your own custom agents. So run this register reply function, pass in whatever you want to run for your new custom function. As you can see here, we have this new check SQL NLQ, right? So check SQL natural language query. And what we're doing here is based on the message that gets passed in. So you can see here, we're just picking up the last message. We're then using guidance, our prompt, and the last message, which is the natural language query that we pass in here, right? So get all auth to users. And then we're able to pull out from the choices we get back from the OpenAI response, specifically the rank. And the rank is what gets set up if we look back at our natural language query right here, right? So it's saying select rank. We're able to pull out just the rank really precisely and get one of these 5 values. This is really cool. By doing this, we're able to deterministically set the responses our agents can have without a ton of prompt engineering magic. The potential here is limitless, and as soon as you concretely understand this concept, you unlock so much value by being able to generate specific responses from your agents. Our entire lives and all of the systems we're a part of, they're all based on if-then statements, right? If sun's up, time to wake up. If 8 o'clock, time for work. If we have an important message from our coworker, respond, so on and so forth, right? Allowing your LLMs to make decisions in your application. Based on the response of your LLM, you then drive different flows in your application just like this, right? This is probably one of the simplest examples. This is essentially an if-else fallback statement, right? But this is a great example, a great first example in understanding that to build complex agentic systems, you need your agents to be able to make concrete decisions that affect the flow of your application. If we go ahead and just run this on some crap, like something like, where's my dog, right? This just makes no sense as a natural language query. We can see that our gate team just rejects this. The confidence is too low, right? So right away, our gate team rejects this. On the other hand, if we do something like give me all job feedback with a rating higher than 3, you can see that our gate team approved this with a confidence of 4, right? We're relatively confident that this is a legitimate natural language query, and this is going to go ahead and run, right? We got select job. We can see our new log ran here with both of our agent teams running now, right? We have the Scrum Master team running, and we also have the data engineering team that ran. So we're recording every chat conversation for every team. So if we come into our data engineering team, we can see, as expected, we have our exact select statement where, we have rating greater than 3. That's great. And if we hop into our Scrum Master team, you can see we have one simple message coming from our admin to our Scrum Master. Our Scrum Master then just spits back the response. It's not saying it to anyone. It's just storing that. And so we're able to get that from the last message and operate on it. So this is awesome. Our agents can now help us control the flow of our application. Okay, so this is great. Let's move on and add some more value to our Postgres data analytics tool. So what I want to do here is create a brand new team. So let's go over to our agents.py file where we're building all of our teams. And in the orchestration here, you can see we're building different teams out. So we've built 3 teams throughout the course of our series. I want to build a new team here, and we're going to call them the data insights. Our data insights team is going to give us unique concrete results based on the query coming in. I want to get interesting insights from our data without even interacting with our data or even having to ask, right? I want to push our Postgres AI tool further. Like let's use the unique capabilities of LLMs and get some cool results out without even asking. What the data insights team is going to do is run a brand new conversation type. We're going to run a conversation flow that looks like this. So we're going to build a round robin conversation flow where given a number of loops, we're just going to run in a circle and let the agents converse to each other over and over again so we can arbitrarily generate tons of insights from our database based on the query coming in. We're also going to utilize guidance again and another custom agent to generate specific structured output. So when our agents are generating these cool insights, we're going to get them in a really formatted, specific JSON format. So we're going to get something like an insight. We're going to get the SQL query to run the insight, and then I want them to summarize and tell me what's the business value of this insight, right? Like if we implement this, what do we get? What do we learn? So let's go ahead and build that out. Okay, we now have a brand new data insights team. I've commented out our data engineering team. We're just going to skip past them and we're going to get right to our innovation prompt. So given this database query, we're going to pass in the query, generate novel insights and new database queries to give business insights. We're then building up a insights prompt, and you can see here we're using both core and related table definitions. If we hop back up to our build table definitions, we now have this related tables database query, which Basically all this does is it looks at all the foreign keys of the tables that we passed in, and it fetches all those tables up to some limit, right? So if there's a foreign key on, say, the jobs table, we're going to pull in up to 2 tables that relate to that foreign key. So that's what that does. And then we're going to get both the related tables and our similar tables. So based on our embeddings, based on the natural language query, we're going to put together all those tables. We're going to get the table definitions, and that's what we're going to use for our insights prompt, right? So we're going to get tables that are used for our data engineering team and a couple more so that we can extend and let our insights team get a little more creative with some more tables. So after that, we build out our data insights team, which has a new unique agent that we'll dive into. We then run a new conversation type called round robin. And as we discussed, the round robin does exactly this, right? So given a number of loops, just loop between all your agents. So A to B, B to C, and then C back to A, right? And if you have 2 loops, just go again. All right, so that's the round robin conversation flow. Refer back to the previous videos to learn how exactly we set up conversation flows. The top level here is we have a new round robin conversation type, which, as we saw here, allows our agents to talk in a circular fashion. And we do have a couple other conversation types here. If we code collapse, we have sequential and broadcast, which can be reflected, just like this. So broadcast is agent A just sends out a large message to B, C, D, E, and F. And then of course, sequential, the most common conversation flow type thus far, A to B, B to C, all the way down to your last agent. So the new round robin enables a different type of conversation flow that our agents can use to create different results, right? And it's kind of perfect for this use case, which is generating interesting data insights. So after we do that, we basically just do a normal check using a match statement, and then we report success or failure. So before we dive into the agent, let's just run this and see what this looks like. So we got approved by our gate team. That is a valid query. And now we're going to run our data insights team. Remember, we're skipping over the engineering team just to get right to this team. Ideally, we want to build out some type of asynchronous functionality because these teams can run in parallel. And as you can see, this is really cool. This is kind of like the amazing part. Not only is our insights team generating cool insights for us, they're generating it in JSON format. So let's go ahead and let this finish. Great. So we got success. We got the total cost. That one cost us about 10 cents. This team is a bit more expensive. Don't just fire these off like I am here. But let's go ahead and check out the results, right? So we've run this a couple times. Let's look at give me all failed jobs. And you can see here we have a innovation file. So this is the insights team. And if we look at this, go ahead and format, we can see that they're generating new novel insights. So, identify the most common reasons for job failures. So it's going to look at this jobs log table, which was pulled in from our related table query. Find out users that have the most failed jobs, super useful, right? So we're going to count, users, we're going to check their name, we're going to interjoin on users, parent user ID. Our agents are not just making these relationships up, right? So if we look at the jobs table, we're looking for parent user ID. Let's go ahead and hit jobs. We can see that that is a completely valid column, right? So they're looking at the tables, they're generating insights, and then we have actionable business value. It's telling us what we gain from doing this, right? I think that's a really nice addition. And this is all just based on the prompt, right? The round robin isn't super necessary here since we can just bump up the number of insights we're creating. It's still a very useful conversation flow to, have in your toolbox. So I figured this was just a good way to, kind of show off that, and you can arbitrarily bump this up. So, say you had like some research team, or maybe you're, writing code and you want to validate your code several times in your agent team, you could just bump up your loops, right? 3, 4, 5 times. There are definitely use cases for a round robin type conversation flow. So really cool there. Let's go ahead and dive into kind of the crux of what's making this all happen, right? Our data insights guidance agent. So let's go ahead and jump into build team orchestrator function, which is what orchestrates building all of our teams. Go ahead and do a little bit of collapsing here so we can see this more cleanly. And let's go ahead and look at our data insights team. So our data insights team consists of 3 agents. We have the usual user proxy, we have our insights agent, and then we have our reporter agent. All the reporter agent is doing is, using a function map to write to a file. We call our instruments.write innovation file, which is just going to, write whatever content we're just given as a JSON file. You can also see our validator here. We went over validators in previous videos so that we know our agents are doing exactly what we want to. All we're doing here is checking to make sure that those JSON files do exist. Okay, let's hop back to our Insights agent. As you can see here, we have another custom agent. Let's go ahead and look at our Insights agent. Just like before, we have a new agent. Same flow, right? Whenever you want to override the AutoGen function calling, use register reply, pass in the function, and then we get these params. And all we're doing here is we don't need to look at any of the previous messages. So we're just saying run this prompt. And this is a guidance prompt that says the following. You're a data innovator. You analyze SQL database structure and generate 3 novel insights for your team to reflect on and query. Format your insights in this JSON format. And this is where a lot of the magic of guidance comes through, right? And they have a ton of examples on their webpage. If you search each, you can see a lot of examples of, generating content with loops. You can see they have an entire character that's getting generated here with just the JSON. So we're kind of doing something similar, except what we want is valuable SQL insights, valuable insights that explain the business value. We want to see the SQL, and we want to see what is the insight in general and just like top level natural language. Then we're just generating 3 rows of this, right? As a JSON structure, temperature set to 7. This is really cool. You can set temperature individually. Pretty incredible. In combination with control flow agents, being able to generate specific output formats is pretty incredible. I got to say, I'm always on the lookout for better tools that can do this. I have my eye on a couple, but I just want to show this off because this is incredible, right? We're now getting structured output from our LLM. And as you saw, if we hop back over to that innovation file, it's doing exactly that, right? We're getting 3 clean insights explaining the business value, and it's also giving us the SQL query, right? So you can imagine a front end where not only are we helping the user query in natural language, we're also just like pushing useful information to them as well that they maybe haven't thought of yet, or that maybe are going to be follow-up queries. So this is pretty incredible stuff. We're enhancing our Postgres AI agent even further. Let me hop back to that agent so we can see that prompt one more time. Generating JSON, we're using a loop, and then we're saying exactly what we wanted to generate, right? Format your insights in JSON format. So that's the prompt. Here's the agent. Agent's in the team. Team gets built by the orchestrator, and the team gets managed at the top level, and the orchestrator runs the specific conversation flow. So a lot of value here. We now have the ability to make decisions based on our agent's output, and we can now have our agents generate specific structured output. Let's light some money on fire. Let's set loops to 2. Let's bring back our engineering team. Let's go ahead and run a full real example. Let's get all products that cost more than $50, right? All products that cost more than $50. Of course, it comes through the gate team first. We now are filtering out bad SQL, natural language queries just completely, so we're saving a lot of money there. We're sending it to the data engineering team. Data engineering team is generating the SQL, running it, saving all that. We're recording all the conversations our agents are having. You can see there we got the product table properly parsed in from Postgres using embeddings and just like a simple natural word matching. And you can see here our insights team is generating novel insights, things that we haven't even asked for yet, things that we don't know we want. It's generating that for us, and it's going to write it into a clean JSON file for us to push to our front end. We are doing the round robin. If we search here, round robin, we got loops 2. So our data insights team is actually going to run twice. It's going to generate 2 batches of insights for us, right? There's another batch. So we're really starting to tap into the agentic capabilities. You can see that second run cost 16 cents. If I summed all the teams up, this was like a 40 cent, half a dollar query, half a dollar run basically. So, be pretty careful with this. Now that our multi-team, multi-agent application has run, let's go ahead and look at the results, right? We have this clean pattern for results. We have 2 innovation files because our round robin ran twice. We have all of our chat team logs we can dig into, and we also have the run SQL result, right? So you can see here, all the prices here are over 50, right? There's nothing under 50. We can just do a quick browse through. It's all greater than 50, which is great. And then we have our brand new insights. We have 2 rounds of insights, right? Pretty cool, pretty incredible, right? These are generating novel ideas that we can then run. And then we have the logs of all of our agent conversations, right? So pretty awesome. You can see the round robin here ran twice. We have admin going to insights to data reporter running the function, and then data reporter back to the admin. The admin then starts over with the prompt, and just runs it again, right? Our building blocks are stacking up. I know that this code base is getting a little hard to follow. I have finally wrapped up the code into a decent structure. I've got it ready for you guys. Go ahead, check out the code base, link in the description. Let me just say a couple words about the code base before you go check it out. This code base is not a library. This is not AutoGen. This is not guidance. This is not something that you can just plug in, play, and just like start running with, okay? This code base is a set of patterns, ideas, and implementations to help you build your own agentic software, right? Use this code base, use our Postgres AI agent code base as an example of patterns and ideas, right? We built out the orchestrator, we built out instruments as a store, we built out conversation flows to control how our agents talk. We built out a clean logging system. These are patterns. The ground beneath us is changing rapidly, week by week. Don't take any code base, including AutoGen, including whatever else you're using. Don't take it as fact or something better than something else. Nothing is complete. Things are shifting and changing a crap ton. What is this series all leading up to? I thought it would be awesome to not just dig into agentic software, not just to like show off patterns and ways that you can build your own applications, tools, techniques, libraries like Guidance and AutoGen, etc. But I thought it would be really cool to end the series with a complete product that you'll be able to use to interact with your Postgres database. Somewhere you can go to just talk to your database in natural language and get results out faster than ever before. At the end of this series, on our 10th video, I'm gonna be releasing an application we're gonna call Talk to Your Database. Link's gonna be in the description if you wanna sign up and be one of the first to see and use the application that we built right here on this channel from start to finish. Over the next 3 videos, we're going to wrap up our application, deploy, build out the front end, and really start making our app battle tested so that you and I can use this application and get real value out of it. The way we interact with our data is changing, so the applications we use to interact must evolve as well. That is what Talk to Your Database is all about. Again, link in the description. Sign up to be the first to know when it drops on our 10th video. Huge thanks for watching. I hope you got a lot of value out of this. If you made it to the end, definitely like, subscribe, and thanks for watching. I'll see you in the next one.